Hello, everyone. We should be live already.
I see that. Should we start?
Let me check. Hello, everyone on YouTube, Discord, Twitch, and so on. If you see us and hear us, please voice up right now. Okay, it looks like we are good.
Okay, so let's get starting. Welcome everyone, and thank you for joining us for this 2-hour session on Cassandra and Kubernetes. I'm your host, Cédric Lunven, and today my co-pilot is Alex Voloshnev. Hi, Alex.
Yeah, it's me.
And as usual, it's not only me and Alex on screen, it's the whole crew, Jack sending all the emails, getting all the venture for the certifications, all the folks at DataStax answering your questions on Discord, on YouTube, and on Twitch, leading by David Gilardi. You know, he will jump on any question you have probably. So let's get rolling.
Yep. We have a great team here to answer questions.
Oh, yes, we do. So today, this is the agenda, housekeeping, basics into Kubernetes, Kubernetes operator, the Cassandra operator for Kubernetes, and we will move to dashboarding, Grafana, Prometheus. It's all about hands-on, so a lot of hands-on today. It's not as much as Cassandra as we used to be. We will jump into Kubernetes very quickly. Sometimes it will be a bit not so beginner as you used to be. It will be a bit more hard, intermediate level, sometimes hardcore, but don't worry. Each time we provide any command to pass, you should be able to do the exercise quite easily. Okay, about housekeeping. So for now, you are looking us on YouTube or Twitch with the streams. But as the comment tab for both YouTube and Twitch are not very great to chat, we also have Discord, and we are there on Discord to answer you any questions. And we will work on either your laptop or a cloud environment, a Linux box we will provide you, and all the materials is available for you on GitHub, so including slides, exercise, command, everything. And you will see that I will probably just read GitHub for the most part of the hands-on. So just as an advice, just to avoid you to switch to one tab to another, because we do have a lot of tabs open today. So first, having the stream on the side is nice, just to see us all the time. Then having Discord to answer question and get some solution about exercise if you're struggling or everything. Support is there. Having the web browser open on the GitHub page. So these GitHub links will be available on Discord, but you do have it here. As I told you, all the materials will be there. We will copy paste from there. So go there and download or clone the repo or working with the repo online. And last but not least, as we will deal with Kubernetes, it's all about the command line today. So we will play with the terminal. It's a lot more ops than the previous workshop that was mostly dev only. Now it's ops today, real thing. And Alex with me today is a real ops guy as well.
Well, I prefer to stay at both sides.
You were both at. Speaking of which, we will do quiz, we will do questions, and to do that, we are using Menti. So best things is to have Menti on your phone, so you can either download the app Mentimeter, or you can open yet another browser, go to menti.com, and use the code 479051, and we will start our session by chilling out a bit, asking you a few questions just to adapt our talks to your level and see what you would be interesting to.
People are asking us so much questions at the workshops, so we decided to make a little revenge. and ask questions you with menti.com, easiest way is just to run it in the browser of your mobile phone with the code 479051.
Exactly. And this is what you should see. And yes, I can see that people are there. So when you're there, please use the thumb up button on the bottom right-hand corner just to tell us you're ready. And oh, it's behind me. Okay, here it is. So 11, 14, let's wait a bit. How many are we today? Let's keep coming. All right. Okay, folks.
While we are waiting, I see there is a question at YouTube chat. So everyone should have got an email with a link to their training instance in the cloud. We use AWS for this workshop. You can do exercises for this workshop in two ways. First, you can install Doaker and run everything on your own laptop, or you can use our training instance. In our training instance currently, you have only one link active, which is a link to console shell in a box. So you can use SSH while staying at your browser, which is great. All the others are not active yet because you are going to run the software during the exercises. So only one link out of 4 will work.
Exactly. So come on, boys, girls, 2 more and we'll go. 1 more. Yeah, let's have a little time for everyone to install the app or open the browser. Yeah, keep pushing the button, but yeah, if you already pushed it once, the number won't.
Let's go.
Okay, let's
go. 30.
Yeah,
we can go.
Let's go. Okay, so we will start with 6 questions to adapt the content of our talking points.
Oh, that's a hard one. Both, actually. That would be my answer. Oh, you can answer both. Okay, and nearly everyone has answered. Are you guys and girls attending for personal development or business project reasons?
Okay, we do have.
Oh, we have even more people now.
Yeah, it's keep coming.
Mostly for personal, interesting.
Yes, you can catch up, don't worry. So next question is, how much experience do you have with Docker?
Never heard about. Known but never use it. Use it once or two. Use regularly for dev. Use it for production. Use every day in production. Well, I started to use Docker before it was mainstream. But let's see.
Never heard about. Wow.
Okay.
Use 1 or 2. You get okay.
But Cedric, take a look how this changes with years. Every next year, I see more and more people. Like we have 6 people altogether who never use Docker in this question.
Yes, that's amazing. I love that, and that makes sense because today we will start with Docker and go quickly to Kubernetes. Okay, so next question. How much experience do you have with Kubernetes?
Well, and I guess answers will be a little bit different in this case.
Okay, use regularly for dev, nice. For prod as well, cool. None, but never used. So if you come back next time we do this workshop, you would be in the yellow one for sure.
That's already upgrade. Sounds great. So most of the people and like the biggest part of the people are or known but never use it or use it once or two, which will not really count. Don't get me wrong. Every usage is great already. But those who are experienced with Kubernetes You guys will have to stay with us for a couple of minutes. We will explain ours what is it and how it works. And those who are novices, don't be in a worry. We will explain what is it.
Yeah, we will go fast. Let's be honest, but we will start by the beginning, and at the end of the 2 hours, it will be deep dive. I can assure you. Okay, what is your operating system? So as I told you, we would like us to install stuff and do hands-on on your laptops and machine if you can. We provide installation instruction for every platforms, but it would be nice to know which is leading today. OS X, okay.
Come on. But actually, we should be able to answer, to make multiple answers, because I use OS X as a home machine, let's say, and Linux on production on our job-related things.
Yeah, that's right. That's right. Okay, but as you can see, it's we do have a balance again today.
Yeah.
As usual. So great. And so for today, are you mostly operations or development or both? Okay. All right.
Yes.
Okay.
Interesting.
Yeah, that's always nice to see both hats. Of course, everybody now, most people now do DevOps, and that's good to see that you run what you code. That's a mojo, right? Okay. Almost there. I think I do have a couple more questions. So, are you working on your laptop, or do you prefer using our cloud environment for today? Yeah, my laptop. That's cool. Yeah, this is what I would recommend. I mean, after all, I just write all the text to make you install that stuff on your laptop. So yeah, that pleased me. Thank you. Okay, and now we do have 40 people in the quiz. It's still coming. Nice. I think that's a live effect. Okay, so that's it for the question. Thank you. Let this tab open because we will do a quiz in a few minutes. Let's say half an hour or something. And yeah, keep the window open. We will go back right here in a minute. Okay, let's switch back to the presentation. And I think, Alex, I will let you go with that.
Give me a moment to switch.
Sure.
And we are good to go.
All right.
So, ladies and gentlemen, welcome everyone. We start the real part. So enough of our questions for a moment. Let us start. So before we start with Kubernetes, we have to clarify a few things. First one, Docker has come. Kubernetes is the basically, we can say, management system, but what it manages. Let's take a look how it starts. It starts from the Docker, and easiest way to compare or realize what the Docker is to compare it to virtual machines. People who say what Docker is basically a virtual machine are wrong, because technically it's a very different technology, but they share some features and abilities. As we can pack virtual machine and run it into another host using the same software, but keeping all what was in the virtual machine within inside. We can do the same with the Docker image and Docker container, but by a much less price. So virtual machine keeps a real guest operating system inside, and therefore it has huge overhead on it because, well, any operation system, even smallest of them, are still consuming some resources. Idea of the Docker was to run containerized application on your own host machine as a native process, but controlled by Docker engine. So it's much smaller, and portability is the same, but by a much lesser price. So images are smaller, easier to start, and without all the overhead of the virtual machines. They also have some downsides, but that's not a Docker workshop. So let us move on.
Yeah, so the idea is to do more with the same infrastructures, because you don't have to run the operating system on each container now.
Yeah. Great. So Docker Engine is a client-server application. Server is a long-running program called a daemon process, Docker-D, and that's responsible for all the management over the containers, images, networks, data volumes, and so on and so forth. And it provides a REST API, which client can use. Client is basically also a console program you can call in your own console, which is a Docker client, just Docker. And you can ask Docker server to execute some job for you, like run a container based on an image, create a network, arrange data volume for the container, and so on and so forth. And in general, how it works altogether. Client asks Docker Engine to do some jobs, like run an image, like let's say Nginx or a Redis application. Docker daemon will ask the registry. Registry is a storage of images, and pull this image to a host machine where it's going to run this container. And as soon as this image is downloaded, image basically is a template. If you aren't so much into the Docker, you can consider image as a template, like precompiled container. Then based on this image, it creates a container as you asked. And obviously, those images can be of a different size. Some of them are very huge. Some of them are very small, like Alpine-based images, for example. But the principle is always the same. When you want to run an image, when you want to run a container, you must specify an image to be executed. Images are immutable, and that's actually gives a lot of cool benefits like caching, layers, and all the other things. And when you want to start a container, so like a precompiled, pre-built application with the dependencies required, you may want to run it differently on the different nodes. Like you have your own laptop, and you have a staging environment, and then you have a production. Obviously, you will have different passwords. You may have different setups. Like if you run Cassandra on your laptop, obviously you want to have single node and simple replication strategy. But if you run Cassandra on your production, settings will be a little bit different. Yeah. So when you execute a Docker run command, you usually specify a lot of things, actually, like environment variables for these containers. You may add storages, specify some networks, open ports. Altogether, running a container may be a very, very long command consisting of a lot of arguments. Like on the right side, we see actually a pretty simple example. Docker run name for the container, detached. Environment variable, Cassandra broadcast address, blah, blah, blah. Ports to open, 7,000, 9,042. Then map the volume and then specify which image of which tag you want to use. And they are running just now one simple thing. Well, not simple thing, but still we are running only one application, which is a Cassandra. When we are going to run multiple services, then you are going to execute like you will need Cassandra, Redis, backend, frontend, some caching. All of them require some settings. And then altogether, you end up trying to handle a dozen of different very long commands. So that's not convenient. What people came to use here is a Docker Compose. Docker Compose is a very simple thing. It's basically a wrapper over the Docker. You describe your required settings to run your application in YAML files, as you see on the screen, and then you say Docker Compose up, and Docker Compose will do all those commands instead of you. So instead of running, like in this case, given the example on the screen, we are going to do at least 2 Docker runs with a long list of configurations. Opening ports, specifying images, giving names, environment variables, and so on and so forth. And with Docker Compose, we simply say Docker Compose up, and we're having all of it, and Docker Compose executes the queries to Docker engine instead of us. So stay lazy, stay efficient, yeah?
Yeah, that's the first step to simplify. But so you can see that Cassandra is available as a Docker image. Kubernetes leverage on containers, so we will use this Docker image. And you also can see that even with Docker Compose, it's not that easy to run Cassandra, because Cassandra is a distributed database with multiple nodes. And even with Docker Compose, you still have multiple services to define. First is Cassandra seed, and second is Cassandra nodes, and you cannot easily scale one of the other. You have to choose. So the command in the top is really to scale only the nodes, but not the seeds. And we will see now how Kubernetes can help.
Yeah, exactly. And well, Docker Compose is great. It really simplifies development locally on, like, let's say, some test environments. But it has one big problem. Docker Compose is natively a single host system. So all you can run very convenient way, but it's still, if you run it on a single host. If you want to run it multi-host, well, you are in troubles. Yes, there are some solutions and there are some approaches. We will not cover them right now because anyway, I don't know how it goes right now, but before, when you run Docker Compose, first thing it says to you, Docker Compose is not supposed to be running in production. It's a not production-ready system. Here comes Kubernetes. Yep. So Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. You can consider Kubernetes as a super upgraded, super powerful Docker Compose. And I know, like, some operations guys will hate me for these words, but if we want, no, seriously, but if we want to explain the things in a simple manner, as Docker Compose manages containers on a single host, then Kubernetes, it's multiple data center size management system to help you automate everything what happens with containers, from the deployment and to the deprecation and deletion and so on and so forth. Today we are going to speak mostly about Kubernetes. So, what are the main Kubernetes features? There are a lot of them. In general, that's all about operations on the containers, services, and other things on the production. So, orchestration for storage, because obviously your application is going to need to store data somewhere. Configuration management and secret management, of course. Automated rollouts and rollbacks, like if you have multiple instances of your application and you want to upgrade them, and upgrade of a single instance takes downtime, you don't want your application to be not available. Kubernetes supports rolling update out of the box, so it will update your pods, your services, we will explain it in a moment, one by one, with no issue, so you always will have enough nodes available and your clients will never notice anything. But service discovery, of course, service discovery is a big thing because modern distributed application, especially with all the microservices things, are going to be a lot of them, and that's much easier when your ecosystem like Kubernetes helps them to find each other without any of interaction with you in fully automated mode. Doesn't matter if you run a single node service on your laptop, or if you're running literally thousands or I don't know, thousands of thousands instances in production, that's perfectly fine.
Yes, that's really dynamic load balancing. You don't have to notice. You will invoke always the same thing, and it will be load balanced to containers under the hood.
Yep, and load balancing is also great. Auto scaling features and others. That's just great. Horizontal scaling. That sounds really familiar to those. Yeah. Horizontal scaling is our favorite scaling. And that's very Kubernetes thing. Self-healing and in general, self-detection, self-monitoring is also great. So if some pods are down, deployment may run a new one, like depending on your settings, of course. And all the other things you may want to run with multiple servers and thousands of services. So what makes Kubernetes cluster? kubectl is an application to, simple console application to execute commands to ask Kubernetes control plane to execute any required actions. Kubernetes control plane, Kubernetes master provides a REST API for the client, so kubectl is a client in this case, to execute any required commands. And then, except of the master node on the Kubernetes, we have worker nodes. Worker nodes are the nodes you are going to have your databases, software, and all the other required things running. Control plane is not so simple by itself because it has a lot of things to do. First of all, it uses etcd as a database. So if you know etcd is good, if you doesn't know, well, it's a pretty simple by the idea thing. And easiest way to call it like key-value storage, and you can store required things there and retrieve them. It's etcd is used by Kubernetes mostly to store all the things regarding your cluster. Controller manager, scheduler, to do some jobs, and API server, obviously, for you to handle all of this and to manage it. Good. So what's the Kubernetes worker? Kubernetes worker is a node which is going to do the workloads for you. So running all the containers grouped by pods. It obviously has a operating system, container D above that to run containers. And it's managed by kubelet via API to manage all the things regarding your pods, scheduling, creation, deletion, and all the other things. And very important concept to understand, if you were using Docker before and know what is it, but don't know Kubernetes, like focus now. Kubernetes pod is a collection of the containers running together, and usually on the Kubernetes, like with Docker, you usually control exact containers. So you have container ID, you can get container logs, you can get blah, 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 and you operate the containers and images. In Kubernetes, you operate pods. Pods is like the normal unit of control in Kubernetes. And pod may consist of one or multiple containers of the same type.
Yeah.
So, important thing to understand, namespaces. Namespaces in Kubernetes are mostly pretty similar to the namespaces in software development. You just want to group up or separate one from another things by their purpose. So you are using library, you are using this library namespace, and you are writing your own code. You use, for example, your company namespace. So Cassandra by default operates with a namespace default, which is a default namespace, but you all, well, I'm pretty obvious today.
Fine.
Yeah, but to group resources, to group pods, deployments, services, and so on. Logically, we use namespaces to separate them. So you have, for example, built-in namespace kube system, which is for its own Kubernetes purposes, default namespace, which is like, well, default namespace, yes, and kube public for other Kubernetes-related things. Mm-hmm. For today's exercise, we will create and use a namespace Cas operator. For example, yeah, Cedric?
Yeah, just saying, so until now, it was all about the Kubernetes infrastructures. You do have the master in red, multiple worker called nodes. But when we deal with namespace, it's logical now, and the namespace live on every node. And when you want to create something in the namespace, it will be allocated to any of the node. And this is why we put the namespace across multiple nodes, because starting from now, we will only talk with Kubernetes object, Kubernetes resources names, and no more telling you about master and nodes, except during the installation, just to explain you a few tricks. But now everything would be Kubernetes resources.
Yes. So yeah, namespaces are logical isolation and, well, pretty global thing you're having on all the nodes. Notice, if you are doing the exercises and you are saying you did some of our tasks for you, and then you are doing kubectl, so calling for Kubernetes control, get pods, and it says no pods available. That's mostly probably because you forgot to specify the namespace. We are using namespace for this workshop, Cas operator. So, as said. So, storage things. It's going very easy with Kubernetes, as long as you are, well, with Doaker in general, as long as you are using ephemeral services, just stateless services. Very easy. Run container or pod, decommission container or pod, and very well, and it's working. Things are getting much harder than you are going to store some data. As you could guess, Cassandra is going to store some data. It was a database this morning. So to work with storage, important thing for us will be a persistent volume and persistent volume claim to grant some pod, to grant some running service. Obviously volume to store the data, and it's going to be a persistent volume claim. So, as said, persistent volume is a storage resource provisioned by an administrator, well, pretty obviously, and claim is a request for this volume. So first, we have some volumes defined, and we are going to claim this persistent volume to get into them, to get for the container or for the pod to use. And storage class is a definition which explains the parameters of the storage, so the persistent volumes can be provisioned dynamically. And my favorite slide. Do you remember how this workshop started with this picture of the airplane in the very beginning? Yeah. So Kubernetes is a big thing. And there are so many everything created. So when you start to work with it, it's getting really, really, really hard. And everything what we have now, that's just like, don't worry. We have very simple workshop exercises for today. Learning by doing. We prepared everything for you. So you just do your job, do the exercises, and don't focus too much on this picture, because we do simple things first.
Yeah, but okay, Kubernetes is really some specification, runtime, of course, but also tons of specification. and everybody can put his own implementation in there. And this is the reason it's not that easy to take one install, even if it's Kubernetes related, all the deployments, all the configuration file from one environment to another, pretending that, oh, it's yet again Kubernetes easy. No, man, no. Any small pieces has multiple implementation, and sometimes is really depending on which one you pick.
Yes. So I like this.
Now you do.
Now you know Kubernetes workshop is over. Thank you for coming.
Yes, thank you for coming.
See you next KubeCon.
Bye.
Okay, no, kidding, of course. Let's go to exercises first. So learning by doing. We have prepared something for you. There are a lot of Kubernetes distributions. You can run it literally everywhere. We today want to work on the local environment of your laptop or on our cloud instance, but still a single instance machine, single node. And people ask, how are you going to run Kubernetes, which is a kind of cluster management system, on a single node? Answer is kind. So kind literally is Kubernetes in Doaker. So when we put Doaker into Doaker, so you can run Doaker while running Doaker. Kind allows you to run Kubernetes nodes, worker nodes, and master as a Doaker nodes. And having one single node machine or your own laptop, you may have everything and multiple servers on your own without any problems, without having a real cluster to manage, because, well, we are still learning. Important, don't forget what running huge workloads is not really well recommended for kind, because it's still a single node instance. That's for education purposes. You have to decide if you are going to do exercises on your laptop, when you will maybe need to do some preparational steps to set up, like Doaker and other things. Maybe you have something already, or you can go.
Yes. So just for that, we will drop the link to start installing Doaker right now in Discord, because it seems that now to install Doaker you need to reboot. It was not the case. I mean, a few days ago. To be honest, I reboot my laptop this morning, and Doaker asked me to update. So maybe it's a release from today. So during Doaker installation process, some folks would have to reboot, and we will wait for them a few minutes. Okay?
Yep. And don't worry. These exercises, even if you can't follow up right now and do them right now, these workshop stays forever on GitHub, and you can do those exercises in your laptop in any moment. Just install the requirements like Doaker, and we have everything prepared for you. And cloud instances we have for you. There is some of them. We can't keep them running forever, but we will definitely stay live for 24 more hours, and you can do exercises today and tomorrow.
Yes.
Good. So let's set up your cluster.
Yeah. So
Cedric, your turn.
Yeah, I shared the link in Discord. So go there and try. Please install what we need for today. And this is Doaker, of course, kubectl, kind. I will do most of these exercises with you, but as I told you, I will give you a couple of minutes to set up your machine just to have at least Doaker installed, and I will do the exercise with you. Okay, so during your installation process, so this is my installation. I already have downloaded, clone all the resources from the repo. Okay, we give you the repo URL in Discord. So it's github.com/datastacksacademy/ Kubernetes-Workshop-Online. Okay. So if you look there, you see that we will have 4 exercises. 0 is the setup. And if I go to set up your cluster, there is README here. And this is exactly the link I provided you in this code. It's really the README how to set up your cluster. So first, you would have to install Doaker. I give you the window link, macOS procedure, tested no later than yesterday evening, but seems like they updated overnight. Linux, same. We did it on CentOS, so it's tested on CentOS at least. You may change to your own Linux distribution, but I guess for Linux folks, you know how to use apt get install or yum or any package installer that you're familiar with. Then Docker Compose. So Docker Compose is really not mandatory. It's useful for you to use things later, but it's not really mandatory for today. kubectl. So both kubectl and Docker Compose are part of the Docker desktop install. Step 1. If you have used the Docker desktop, you're good to go. And or if you're using brew, well, that for Mac, brew install kubectl. So brew install, homebrew, superstar in macOS, yum install in Linux. And there is something quite equivalent in the Windows world, and people are not aware, and it's called Chocolate. And so if you install Chocolate, you can start doing choco install XYZ, depending on what you want to install. Very convenient, very convenient. And for kind, which is the last pieces we need to install, you would do choco install kind. But of course, you can still install with using the exe or MSI if it's an archive, to run as is.
Last time I've used Windows like, I don't know, 10 years ago or maybe 12. So it looks like something has changed.
Yes. And so with everything, you should be able to say kind get clusters and have no kind cluster found. I hope it's big enough. I can make it again.
Yeah, let's make it a little bit bigger. While we are speaking, so for those who are using not your own laptop, but for those who are using our cloud instance, you should have all those steps are done already. So you can start at the step 7. If you are using cloud instance, then you can start with the step 7 to create namespace.
And or wait for other.
Yeah, and wait for others who are installing all the things.
Yes, we provide you a cloud environment, and most of the things are already installed.
Yep.
And you can start step 7, but I need to do step 6 because, as you can see, I don't have any kind cluster yet.
Yep. And when you are ready, we kindly ask you, thumbs up in the Discord, in YouTube, whatever, however you are watching us today, because we want to know when we can move on.
Okay. So let me start. It's only 10 minutes. I will create the kind cluster.
It takes some time.
Yeah. So as Alex told us before, kind is one of way to install Kubernetes on a local environment. See, kubectl is only a client. Kind is really the runtime that will have everything in Kubernetes. So the control plane, the REST API, and multiple nodes. And this is a reason why we don't use Minikube which is also very famous in the Kubernetes world to work locally. The reason is to install a multi-node cluster, Cassandra cluster, you need to have multiple workers in your Kubernetes environment. There is a way to trick that by putting settings in the YAML files, but let's get things simple and use kind, which has been designed for that. So if I go to GitHub and I open the kind config file, kind config, you can see that it's, okay, let me that bigger. You can see that it's very, very simple. It's really, I'm starting a new cluster named kind Cassandra with 5 workers, and that's it.
Yep, so using this configuration, kind will create altogether 6 Doaker nodes for us. Oh, sorry, Doaker nodes, Doaker containers, and they will play as Cassandra nodes. So you have all the Kubernetes power right at your laptop.
Yeah, so that is the creation. So now if I do kind get clusters, I do have a new cluster named kind Cassandra. Oh. Wrong copy paste. Copy, clear, and paste. See, I do have a single cluster named kind Cassandra. I'm going slow in the beginning on purpose to have everybody install all the stuff, and then we will move on. So remember, if you are using the cloud environment, everything has been done for you already. And now I will tell the kubectl, which is Kubernetes client, to work with the server, the cluster we just defined. So now, each time I will use kubectl command, I will interact with this cluster we just have created. So if I do kubectl get nodes, as you can see, I do have my control plane, my master, right? And 5 workers named worker, worker 2, worker 3, worker 5, worker 4, and 5. And this is one of the last time I will show you the infrastructures. Now we will work using logical namespace. This is what we show you right before that. Okay, so I see somebody listed the namespace. So kubectl get namespace, namespaces. Okay, I only have the default, name default, as said by Alex before. And so let's create a new namespace named Cas operator to have everything, every resource we will create be part of the Cas operator namespace. And if you want to get rid of that later, you can totally delete the namespace and it will delete the resources accordingly. Pretty easy to just have everything at the same place and listed only what we are doing today.
Be careful with it on your production.
Okay. So kind is really run. I see a question on Discord. So kind is really providing both a master and multiple workers, and it's all in kind. Kind is really the big virtual stuff on top of everything.
Notice, kind is not really used in production. You need kind to run Kubernetes cluster on a single machine. That's the easiest way to do it at this moment. Like before we had Minikube, now we have kind. Kind is kind of more inconvenient to use in some questions.
Yes, it's more kind.
Yeah, kind is kinder.
Yeah, I like it. Okay, so we created a namespace. Let's put some stuff in the namespace. So the first thing we need is a storage class. So part of the storage component in the Kubernetes world, it will describe how you provide disk space to each node, each container you want to run. And the storage class is really it's a specification. You have to define your own depending on which environment you are running. So to do that, I provided a couple of commands. So you need to describe what is a standard, and you will duplicate the standard to create a new one called server storage. And with server storage, you can edit and change whatever you want. So I'm not reading everything, but this is what it looks like. The YAML file, storage class, for kind. So it's named storage class, server storage. It's a storage class. And most important things to notice here is we are wait for first consumer instead of default value, which is immediate. And this is really important to have the proper pods to be properly bind with the storage class. So everything that I show you is also part of the file storage class here, storage class kind. I did the same for Minikube, and folks at DataStax used to work with GKE for most of their tests, and they're providing a sample to run to have the storage class on GKE. So the kind, no surprise. Let me put that bigger. Okay, wait for consumer, named storage class, and I'm using the provisioner, okay, related to kind. All right, so let's execute this command to create the storage class, will you? Okay, so kubectl create, where is my command to create my storage class? Where is it? Apply storage class. So to install something in Kubernetes is really sending a YAML to the REST API, so kubectl communicating to the REST API, sending a manifest with all the objects to be created. And so now it's created, and I can list again my storage class, and I do have a new one named server storage. Okay? And that's it. We are ready to move on. We have just created an empty Kubernetes cluster with a storage class. Okay? So seems like HS81 is ready to go. Please put some thumb up, and I will go back in slide mode to just explain what we will put inside this nice empty cluster. Because if you look at the stream now, this is exactly what we have created. We have created the CAS operator namespace, and we have defined a storage class named server storage, but nothing else. We have a lot to do now. And it would be the most interesting part. Installation is always painful, right? Okay, I see some thumb up. Yes, I'm just seeing a question about running multi-VM setup on my desktop, but yeah, I don't know what it means.
So, ladies and gentlemen, if you are ready, thumbs up. We are waiting for you.
Yes, please. Because if you're not ready there, it will be hard to keep up later on.
But again, don't worry. If well, you see, efficient engineer is a lazy engineer. Cedric is going to do all the job. So you may be efficient in this way, grab your tea or whatever, watch Cedric doing that job, and then do all the exercises with understanding of all the steps. It also works.
Yes, so purpose of today, again, we provide you all the instruction to run all the exercise on your own, including solutions and why we did that. So, and I will do the exercise in front of you, but it would be better for you to do it right now, just to have a hands-on on it. That's really the meaning of this workshop, having hands-on and having a working sample on your machine in the end. Okay, we are almost at the top of the hour. I will move on to just explaining few concepts before going back to exercise. Kubernetes operators. So until now, we have defined what is a pod, what is a storage class, what is a namespace, what are existing resources. So let's focus just a bit on the pod. When I create a pod with kubectl, I will invoke the API server. I want to create my pod. And then I won't go into all the details, but you can see that etcd will store the state as the scheduler to trigger something and invoke the kubelet, which is an agent on a worker, to start something, Docker run. The container is running, probably multiple containers inside the pod, and boom, 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 we get the status. Okay. When a pod will start, it will first initialize, and as you can see, it will be in starting mode, and then in the end, it will be ready. So when the pod, when the container is just starting, I would say I will provide a probe named liveness probe, telling you that, okay, now your container is starting, is living, but is not yet ready. And I do have a second probe named readiness probe, telling you that, okay, now the pod is ready to go, and I can move on and I can start interacting with this pod. And I felt very important to show you that right in the beginning, because each time we will create some component in the Cassandra world, like nodes, we want to know when the node is ready to accept new data. And we will need some probes to do that. And we will also see how to implement those probes, or how those probe has been implemented in the Cass operator. All right. Okay, so after the storage class, persistent volume and persistent volume claim in purple on the schema, I would like to introduce you what is a stateful set. If you run stateless application like microservices, Spring Boot, Magic World, you can only run pods, and you're very happy about that. It's stateless. If you kill the pod, Kubernetes will put another pod back online. And depending on how many pods you asked, a replica set, Kubernetes will make that possible. But with a database, you must understand that in the database there is data. So you don't want to lose your data when you lose a pod, right?
Come on, we always can find new clients.
Yes, so that's probably better to have storage, okay? And so the storage, it's done with persistent volume. In the Docker world, we talk about volume. In Kubernetes, it's persistent volume. And storage class is the specification, the one we just defined. And we will create some persistent volume. And we will associate the persistent volume to a pod using a persistent volume claim, PVC. And so you will see that with the Cassandra operator, we will create STS, stateful set, and this guy will create the pod, both the pod and the storage for the pod. Okay? Stateful set, very important. I will stop with the animations. Next, very important is services. I won't go into the detail about ingress endpoint network policy. Very for today, let's go quick. let's jump into services. Yeah.
So Cedric, I want to say a word on it. Notice one big difference. Service in Kubernetes is not what you usually think of as services in any kind of software development thing. So Kubernetes name service is a little bit misleading, or maybe, well, not misleading, but it, let's say, conflicts with a normal, regular understanding of what a service means. So don't think, I know service, I'm good. Listen to Cedric.
Yeah, so let's read the definition, will you? So service is a named abstraction of software service with port to listen and the selector to determine which pod will answer request. So instead of invoking the pod with its IP, I will invoke a service, and the service is the abstraction, is the endpoint on top of my pod. Can do the load balance if it has to, can do the name resolution. I will really work with services. And each time we will create new resources in Kubernetes today, we will also create new services to be able to interact with those resources. Next is configuration. When we will install Cassandra, we will define some user and password. Okay, so in the Kubernetes world, you store all the credentials in resources named secret. So secret old data, and values are encoded in base 64. So that's for secret. And the other is configuration map. So key value, properties, init file, tends to you use that probably already in your application. So config map is loaded as a set of environment variables available for the pod. Okay, it will do all the system.set property for you, and in the pod you can access the environment variables for keys and value in the config map. Okay. And then come the big pieces, the most important pieces for today. What we called a custom resources and how to define them with a custom resources definitions. As you see, there is a lot of existing resources available in the Kubernetes cluster. Pod, replica set, stateful set, storage, everything I just show you. There is many, many more. But sometimes you want to create your own app, your own resource with its own rules, because you want to do some long running task. You need to wait between two tasks, waiting for flags to be up to be able to move on, or wait for statuses. And so you create your own object. Your own object is called a custom resources. To create that, you will initialize a manifest telling that you are doing a custom resources definition, and you will provide a part named the spec for specification. There, you will define the keys and the state you need your resource to have. So configuration settings, default values, and properties. So if you want to create your own component, each time provide spec. So here I show you a sample. If I would like to do some cron tab resources, I will ask to get the cron spec, the image to run my cron, and replica, how many times do I want. This is me defining this key as parameter. Second important is the status. Describe the object status, the observe state. Remember, you provide a state to Kubernetes. This is what my application should be. And if some things go wrong, like a pod is just killing, Kubernetes will compare the current situation with expected state and will reconcile the state, starting the new pod if you have to start a new pod, or changing the configuration if the configuration is not the same. And to do that, you need to leverage on a field named status. The status like everything else in Kubernetes, is a resources, is the REST resource. And so you can access this resource to get the status and interact with this custom resource. And then, what is an operator? Well, the operator is what will monitor your customer resources. This is the guy that will reconcile the instances, so the current running application, with the states you define in the first plate, the spec. So if I put in the spec, I should have 3 pods running, and at the moment only 1 is running. The operator will notice that there is a discrepancy between the spec and the current state, and will act accordingly, asking the CRD to do some actions to go to the expected state. So the CRD is interacting with the REST API in Kubernetes as everything else, and the operator can subscribe, through event handling to events coming from CRD. So it's not only the status, but it's also every time something happens and the CRD publish some event, the operator can be there and work accordingly. And this is why I put some arrows, both in events, it's really using the API, and reading states in the etcd, but not accessing etcd directly, always using API as usual. Okay, so to run Cassandra in Kubernetes, you need to leverage on an operator, because in Cassandra world, there are a ton of rules. You cannot start multiple nodes at the same time. Sometimes you need to have an order, and so you need to wait for the first Cassandra node to be up and bootstrapped to get a new one. And each time you need events and some kind of scheduler, orchestrator to know that we are creating the resources at the good moment.
I would say it this way. You technically can run Cassandra in Kubernetes on your own, but you should not. Or maybe to say you don't want to do it because, well, all what Kubernetes, all what Cassandra operator does, there is no magic. That's understandable, logical chains of events, let's say, and you can do it all of your own. But efficient engineers are always lazy. Lazy engineers not always efficient. But let's take a look. Like you don't want to do manual job if it was automated already. Cassandra operator automates operations with Cassandra at Kubernetes.
Yes. Oof, that was quite some definitions, right? So let's see if you paid attention. I think I let enough time for everybody to have his cluster running. Let's go with a small quiz about Kubernetes. So let's move to menti.com, or the tab already open for you, and let's proceed with a quiz.
It's the same code and the same quiz, yes?
Yes, it is.
Yeah.
Yes,
so
it is.
If you have Menti opened already, you don't have to change anything. That's the same code and the same site, and you are still at the same quiz. Stay with us.
Yes, totally. Okay, so I'm waiting for some thumb up. Then I will start the quiz. Because this is the first question for today, you will have to provide your names. So I will wait for you to enter your name before going to question number 1. $19. 20. Yes, we can do better. Okay, so let's go for the quiz. I can see some people keeping thumb up, you see all the thumbing up. All right, let's go with the quiz. Now it's time to enter your name. It's only 6 questions for today. It's a 2-hour session. Let's make it quick. All right, 19 as before. Okay, we're starting. 1, 2, 3. Here we go. Waiting for player. 33 already? Where this guy is coming from? That's funny. More people in the quiz than people thumbing up. Okay, that's fine. Okay, let's get running. I start the quiz. Boom.
And notice, answer fast. Docker container is.
An image of software stored on disk. A lightweight standalone executable package of software. A file used. Go.
File, yeah.
A file used to configure a Docker instance. And probably the last one, some things to store fish.
And, well, most of you answer it correctly, but thing is not to only answer quickly, but also correctly. A Docker container is not an image of a software stored on disk, but something created out of this image.
Yes, the image is immutable, and when you instantiate the image, you get a container, and it's really executable. Okay. Question 2. No.
First leaderboard. Hey, take a look. I'm in the first line. Okay. Sorry,
okay,
guys.
Alex.
I will slow down. So the real first place is Vinesh.
No. Somebody needs to be faster than you. Okay, guys.
Yeah, I will slow down. Don't worry. Vinesh is the first place, real first place, and then Roger O, and then Tren.
All right.
We are ready to go on to the next question.
Go.
Fast but correct. In Docker, how do you enable persistent storage of an application state? You don't. Persistent storage doesn't exist. Nothing is real. Nothing.
So Docker, not Kubernetes. Pay attention. And yeah, most of you got the correct answer. Yeah,
yes.
So in Docker, we are using volume. Yes.
Please, we have some tricky questions, so stay careful. Watch your answers. The question was in Docker, and in Docker, persistent storage is a volume, not the stateful service, and no things like that. It sounds similar to Kubernetes. Stateful sets.
Yes. Okay, and now?
Okay, you see some people are, okay.
So Vinesh.
I don't count. Vinesh, Adarsh, and S-Kids. Yes, go people, go.
Yes, let's go.
Cedric, do we have some swag for today?
Of course we have.
Yeah.
People in Kubernetes, what is a pod?
Oh, I don't know.
That's a tricky one, yeah.
Yeah.
I honestly have no idea, and this is the first KWS question you ask. Okay. Probably not the correct answer.
And the correct answer is a collection of containers what can run on a host. And that's right. Pod is not a worker machine in a Kubernetes cluster. Node is a worker machine in a Kubernetes cluster. Correct answer number 3, collection of containers. What's the results? I was very slow today with this time.
Are you?
Yeah, I promise I was. Oh, Vinesh, it was a mistake.
Oh, jeez.
Okay.
And now okay, Alex.
Now I have to really stop.
Oh, that's funny.
Come on, I deserve a t-shirt. Seriously.
Okay, one t-shirt for you.
In Kubernetes, what is a service? It's a tricky question.
I mean, Yeah, you made your point before. We spent a long time on the service today, so hopefully it's something you order in your room at a hotel. I like this one.
Yeah, me too. Kubernetes hotel. Okay, two people. Well, one was me. Correct answer is service in Kubernetes is a named abstraction what defines a set of pods. Seriously, I told you it's a tricky question. Nope, in Kubernetes, service is not a program what runs in the background. I warned you some minutes before. And no, Kubernetes is not a policy what describes network traffic as allowed for the pods. That's not a service responsibility. Service is a named abstraction what defines a set of the pods and maps them.
Yes. Abstraction.
Leaderboard. Okay.
Boom.
Yeah. Now ask kids. Adash,
okay.
DM and Gaia. Oh, sorry, I really have.
DM and Gaia. Yes. Andrew, Benoit.
Okay.
Okay, let's move on.
We have one more question, am I right?
Yes.
Last one, no? Let's see.
I think two more.
A Kubernetes operator helps create a custom configuration. It helps. Well, usually it helps. Extends the type of application what can run on Kubernetes to deploy pods to ensure your calls get routed to the correct destination.
Yep.
Correct answer is helps to extend the types of application what can run on Kubernetes.
Yes, it's custom, but it's ready to extend the type.
Answer, what Kubernetes operator helps to create a custom configuration is not really correct because the Kubernetes operator is by itself a custom configuration. And well, Kubernetes operator does help to deploy pods, but that's definitely not the main definition.
No. Leaderboard and...
Okay, and that's a twist. How it goes in the end. Adarsh, first place.
Yeah, good
Congrats.
point. So take a picture and contact Mr. Jack Fryer on Discord for t-shirts. I think it was the last question. Oh no, one more. I think it was.
Oh really? Oh
yeah,
okay.
yeah. I think six overall.
Data Stacks Kubernetes operator for Apache Cassandra describes what network traffic is allowed for a set of pods, represents customization of a particular Kubernetes installation, automates deploying and managing open source Apache Cassandra or DataStax Enterprise in Kubernetes. Time is up.
Yeah, this one was easy. Of course, you need the operator to automate deploying Cassandra in there. Yes.
Yep. DataStax Kubernetes operator helps you to focus on your job without juggling the pods. Oh, and
okay. Yes.
Andrew was so close. Adarsh, first place.
Yes, he's still there. No worries.
Contact Jack Fryer. You deserve some things.
Yes, you do. Again, keep this tab open for the question in the end, please. And I can move on to yet another few slides, and let's switch full hands-on after that. Okay. Let's discuss about the Cass operator, Cassandra operator. Will you? Okay. So we didn't even explain what is Cassandra in the first place today, so I put back this slide just to tell you. Apache Cassandra is a NoSQL distributed database. It can be used for multiple use cases. We do have multiple workshops recorded to deep dive into the Cassandra world, but most use case is really to do distributed database. So as you can see, multiple ring around the world or multiple node around the world or distributed in multiple cloud providers. So this is what looks like Cassandra topology. If I would like to put some names, the full Cassandra installation is Cassandra cluster, okay, in blue. In a Cassandra cluster, I can have one or multiple data center or ring. And it is marked here in purple. Okay. In the ring, you will define Cassandra nodes. So nodes are orange. Nodes are one server hosting Cassandra. As I told you, Cassandra is distributed. So we expect you to have multiple servers running Cassandra and not a single one. There is no point to do it with this technology. In a Cassandra ring, you can tell Cassandra, oh, these two nodes are actually installed on the same rack, maybe the same location. And when Cassandra will distribute the data around your ring, Cassandra will pay attention to avoid sending the same data, if it can, in the two nodes, just to be as resilient as possible. And grouping or telling Cassandra what are nodes close to each other, this is what's called rack. And rack here is in red. Okay.
I want to notice a thing about the racks. There are two kinds of racks to consider. When you have your own bare metal data center and things like that, then server rack is for you a real server rack, like from metal with all the power cords and so on. And if you run in the cloud, then thing is different. Rack still exists as a definition, but it means simply an availability zone in a cloud. So it's the same data center, just another availability zone. That's it.
Yes. So your mission, should you choose to accept it today, is to put that Cassandra cluster into our Kubernetes cluster. What a challenge. It's not the same dots. Let's see how we do that. Okay, so the features of the Cassandra operator is really easily running Cassandra in Kubernetes, meaning ring initialization, seed node management. On the contrary, as Docker Compose, I told you that. So seed nodes will be handled for you. We will create one per rack. Remember the green in the slide before, or 3 per data center, and each time whichever is more. We will create a new resources, custom resources, remember, and it's a Cassandra data center. So the CRD is based on the data center, not the full Cassandra cluster, one data center. So in the slide before with 2 data centers, 2 rings, I would have 2 custom resource definitions. So I can rolling reboot the nodes in there. I can store data in multiple rack. I will show you that in a minute. You can scale up, you can scale down, and it's work with multiple DC cluster. So let's see how it look like. With the exercise. Okay, guys. So now let's move to section 2. If David can share the link on Discord, I share the link here, and I will go through the different steps now to install Cassandra inside Kubernetes. Okay, let's move to console mode. I will clear here. And I will also go to the proper exercise. So like you, going back to the root, part 1, Cassandra, boom. And I go to the README, and this is what I need. Okay. So I will move a little faster now. I expect you to have everything set up. So first we need to do is to install the Cassandra operator. And to do so, we will use the Cassandra operator manifest, and we will apply the manifest. So there is a bunch of resources defined here, and we will create that. So I can, go.
For those who isn't so much into Kubernetes now, let me repeat a thing about how this command works. Can you please Control-C to a previous command? So you see in the very first line, Cedric runs a command, kubectl -n cas operator apply -f file name. What's going on here? In the first line, we ask kubectl client of a Kubernetes to apply change set, which is described in the file name and file path, and we are going to apply it to the namespace cas operator. That's what's going on right here. So basically, Cedric creates all the resources and installs cas operator, describe it in the file. What's in? Be curious and check it on your own.
Yes. And so then I just ask Kubernetes to show me the status of the pods running inside my namespace. And I do have a single pod named cas operator, my operator running, and it's ready and running. So let's do that on your own. And this is exactly what I did. So I go back just to show you in a slide what are the resources I created in my namespace by using this command. So I use a deployment to create a pod for the operator, but also not only a pod. I also created some webhook, some security, some roles to be able to register my operator into the Kubernetes cluster. I've created a secret to interact with my operator and a service, just to say my operator is running. So one service for the operator to interact with the operator and one service for the webhook. Okay, this is what I've just created. Let's go back. So as you can see, my cas operator has a unique ID here. And I should have, yes, something like a block note ready to go. Okay. Because I will describe my operator. So describing is really showing more details about something running. So any resources. So here is my pod. So okay, copy paste. And here you can see all the YAML describing my pod cas operator. And in the end, you can see that what are the events happened. And so I've pulled the image and I've created and I've started my operator. This one is very fast, very easy. I've created what I need to. I provide you some comment here if you want to know what else have been created. I show you the slide, but you can list the services, the secret, the config map, and the Cassandra data center. Oh, I can go with the Cassandra data center 1. Guess what? There is nothing to show because for now, we didn't have created anything. We just have installed the operator, but it's not an error. It's just telling me that this kind of new resources you just create, my custom resource, my CRD. So my CRD is named Cassandra Data Center. You can also name that CasDC. Yeah, there is nothing there. Okay.
Yep.
So
now operator is running, but we never asked this operator for anything. So it's just running idly.
Yes. So now I will apply a file to create a cluster in Cassandra. So if I look at this file, because just before running the command, maybe we need to see what we are doing. So this one is one node cluster. I will create a Cassandra data center. What a surprise.
Sorry, Cedric, could you please make it a bit bigger and...
for this one,
yes. Yeah, command plus. Yeah, perfect.
All right, let's go for that. So I will create a Cassandra data center, resource definition, and this is my spec. I need to use Cassandra 3.11.6. I will have a cluster name cluster1 and the DC name DC1. So the big blue is cluster 1, and I install a single data center. Remember the purple one, and I do a single one. And if I want to create a new data center in the same cluster, I create a new custom resource with name, let's say DC2, and providing the same cluster name. And the operator will know I will put those two data centers in the same cluster. I also provide a spec. So as you can see, it's a single node cluster. I will use the server, the storage class we defined together, storage 1. This is the storage capacity I provide. And I can also provide some key value, specification. The Cassandra container, remember the Doaker image? Accept keys to override property in Cassandra YAML, like that. We didn't do anything about that. It was part of the Doaker image. And we provide keys, and it will be they will be overwritten. So we will use password authentication. So we will create user password. So let's go and apply this. Okay, DC1 is created, but guess what? It will take a few seconds to really have something started. So I will watch the progress. So I will go there and watch the progress. So as you can see now, there is a new pod. This pod is name of the cluster dash name of the data center dash name of the rack. Remember the green one, but here we did not provide any rack. Then STS for stateful set, because we create a stateful set per rack. And finally, dash 0 is pod number 0. So now you can see that it's running, but it's 1/2. So it's living, but it's not ready. The readiness probe is still false, but the liveness probe is okay. And it will take a few seconds for my node to be fully up. I will put that back. And it's running. In the same time that I'm creating my pod, the Cassandra data center DC1 also evolved. The status start with updating, and when everything is okay, the status go to ready. And you could have seen that also by typing the command cas operator get -w casdc Cassandra data center -o YAML. Oh, I should have removed this part, to be honest. But yeah, now my pod is running, and if I describe my DC, so describe casdc DC1. Now Cassandra operator progress is ready, and this is everything I did. I created a service, created a stateful set, created a pod to start a Cassandra node, and I've started everything I needed. So as you can see, I use casdc or data center. Those are synonym. This is the expected output. And so let's see what we can do with that.
Just a second. Can you open back these events? I mean, they are now hidden. Yep. So take a look. If you still have a question, why do I need Cassandra operator? Why can't I run Cassandra in Kubernetes on my own? That's exactly the answer. If you're running Cassandra without Kubernetes, without the operator, you're going to do it all on your own with not a single command, but with, well, pretty long list of things to do and things to care of.
Yes. So what happened under the hood? So that was our first command, creating the installing the operator. Now I've defined a single node cluster. I've specified a specification like that. Okay. And boom, just by providing this YAML, I have created a CRD DC1, a secret super user. Remember, we tell Cassandra we need to use user password. Single rack, named default, single pod for a single Cassandra node. I provide this node a storage, and I use the server storage, my storage class. You also created dedicated services, so the services for the data center, a services dedicated for the seeds. Remember the Docker compose with seed and node. Now we have something specific for seed, and all pod services. This one is used to scrap metrics and push that into a monitoring system like Prometheus, for instance. Okay, by a single YAML, this is all the resources we just defined. Let's move on.
Okay. It may be, sorry, Cedric, people, it may be overwhelming. Kubernetes is not a simple thing, and you may be just already like, okay, that's too much information. Don't worry, step by step, don't be in a hurry. Take it easy.
Yes.
I mean, every time you show things like that, like picture, so connections everywhere, it's hard in the beginning. You will handle it, don't worry.
Yes, that's not easy. Yeah, that's not easy at the first place. I agree, but yeah, we get used to it. And we're just executing a bunch of commands and everything happening under the hood. I'm digging very into the details for you to understand, but you can go and execute command one after the other. So if you're familiar with Cassandra, you can getting the username, which is cluster1 super user, and password out of the secret. So to do that, I copy paste the secret, the password, but as you can see, it's encoded in base 64. So I will simply go there and echo my password. Like that, and ask him to put it back in something I can read. More or less, it's still a password, yes. So this is my password for today. Okay. And so I can totally do the same for the user, but the output will be cluster1 super user. This is exactly, that is always the case because we have created a cluster named cluster1, and we will use super user. Okay. And now I can go to I can go to the running pod by typing the exec-it. So now I am in the running pod. Okay. And I can try to do node tool status, which is a Cassandra command to say, please show me what my Cassandra cluster look like. Single node. Yes, this is expected. As you can see, I'm just copy pasting command like that. And so now I will use a service name. So remember, I don't use direct pod or IP. I use service, which is an abstraction. So I can use the service name cluster1 DC1 service Cas operator to be able to log in to one of the nodes. So -u my user, -p my password. So this time I cannot fully go copy paste. I need to provide my password here, playing a bit. And here we go. We are now logging in a tool called CQLSH, which is a tool to work with Cassandra. And as you can see, I can interact with my tables and start typing some data. So next command is really to deals with SQL, insert tables, do some stuff. So describe key space, this is what I did. He will explain you how to create a few tables and how to insert data into it. I won't do it in front of you. This is really just copy pasting the command. Create table, inserting some data. I will just exit to move forward with the Kubernetes part and not Cassandra part. Okay, so I can go CQLSH by providing the proper username and password coming from my secret. Okay, now if I compare the Cassandra -cluster-1 node to Cassandra -cluster-3 node, the only difference is the attribute size. I can go to the YAML and see it's exactly the same, it's just size. So I will apply this file. So remember what will happen. The Cassandra operator will detect that the CRD DC1 has a state different that expected state, because now expected state is 3. So it will send proper events to the CRD to create new pods. So let's do it.
Usually you don't run Kubernetes to have single node Cassandra cluster.
No, that's overkill, right? And I can watch my pod initializing.
Yeah, some new guys are coming.
Yes, and in the same times I can also see what's happening with my operator and my data center DC1. It will be in smaller, but yeah, he's not happy. I didn't copy the kubectl part. So let's see. So the small one is really just to say, look at that. It's updating because it's still working. I have created 2 new pods, but those pods are initializing, meaning creating the pod, creating the persistent volume, attach the persistent volume to my pod using a persistent volume claim, starting my nodes. So it seems like now my pod are starting, they are leaving. Liveness probe is up, but readiness probe is down. And I will wait until I got 2/2 and my 3 node cluster running.
I want to add something and meanwhile answer to a question what was asked. There is a thing in Kubernetes called affinity. We didn't touch this thing during this workshop because, well, we can't explain all Kubernetes in 2 hours, but affinity, anti-affinity, node selector are things which allow you to choose where the pod should be running and where it should not be running. The idea is to run different replicas of Cassandra or any other application you may want to run on different physical nodes or, well, virtual machine nodes to keep them available even if a single node or virtual machine is down. So Cassandra operator cares of things like that. So those pods will be running on different machines, like all what Cedric said before with racks and data centers. It's considerate.
Yes. So I will need my other, yes. Okay, so it's still updating. And I do have one of the pod ready to go and only one remaining, and it's still starting. So if you keep reading the exercise, what is asked is really go back to SQLSH, look at the data you created before, and make the data you created before use the 2 new nodes we just defined by using a command named alter key space. Again, today our purpose is really Kubernetes only. So now I do have running. Okay, this guy's almost done.
Oh, it's ready.
Did you see it? At the second this one was okay, this one switched to ready. Okay, that's really how it works. And now my DC1 is matching the manifest I provided before, size equal 3. If I provide a new configuration, let's say in the Cassandra YAML, I want to change one parameter, let's say the memory used. This is a key in the YAML. I change my manifest in Kubernetes. I apply my new manifest. And then the Cass operator will do a rolling restart of my pods, applying the new settings. So I can show you what it looks like. So this, in the changing my configuration, I apply a new configuration. I can show you what is the difference. It's a parameter in the memory, I told you. Okay, it's commit sync period. I would like to change that. So I will apply my new config, and guess what? My CRD is not in the expected state. Operator need to work and start applying the new states, and this guy will be yet again updating, and our pod will go into rolling restart. Okay, this one is terminating. We put the new Cassandra YAML, we restart, and we do rolling restart for you. So even if it's distributed, the Cass operator will do the rolling restart for us.
Yep. This setting, commit log sync time setting, is not a simple thing. So it requires a service to restart to be applied. It can be applied live. And now rolling update is what I told you before. When we have to restart the system with some settings, we don't restart all the pods at once because it leads to downtime, obviously. But rolling update is update one by one, step by step. So you always have enough machines available. And that's what Kubernetes and Operator are doing for us together.
Yeah. So I will let my pod restarting, and I will simply go back to a slide and show you what happened. So this is what we add, single node DC, and we first update the size of the cluster. So instead of having a single pod, now I do have 3 pods inside a single rack, materialized by a stateful set, inside a data custom resource definition DC1. I didn't change the services. I didn't change the secret. I simply add new pod and new persistent volume. So 1 persistent volume per pod, 1 pod for each Cassandra node, and this is how they are distributed. Rack as materialized by stateful set, and DC by custom resource definition. And like that, we can have multiple DC inside a cluster, but you can also have multiple cluster drive by the same operator instance. It's all defined by 2 properties, name, which is a data center name, and cluster name, the name of the cluster. And remember that probes, I told you, oh, my node is leaving but not ready, and the other way around. Now it's probably leaving before be ready. Well, in Cassandra world, by default, it's not that easy to know when the node is ready and the node is not ready. To do that, we're providing inside the pod and close to Cassandra yet another container called a sidecar. This is a famous pattern in the Kubernetes world. We have created an open source a Cassandra management API, which is a REST API running as a sidecar inside the pod. And the Cassandra operator will poll these endpoints to know, oh, this node is ready or not ready. And under the hood, the sidecar will try to connect to Cassandra, do some SQL command just to see if the Cassandra node is okay or not. But it's providing you what Kubernetes expects, which is a REST API to know if the pod is leaving or ready. Okay. Tuk. And we scale up that little guy. Okay. And this is all the events happening when I scale up, but I won't go into the detail. Okay, so that guy is running, and that guy is, oh, it was still updating, so I will let him update. But nevertheless, you know what? I will keep moving. Okay.
In our cloud instances, it goes faster than at your laptop.
Really?
Yep.
Okay, so now everything has been restarted. Nice. So this one, exercise number 1 for Cassandra. Exercise number 2 is really showing the data center in the Kubernetes dashboard, but it's really nothing to do with Cassandra, so I will skip that with the timing. I will go through directly to the last part, which is Prometheus Grafana, which is monitoring on top of these Cassandra nodes.
And if you're responsible for maintaining site reliability engineering or things like monitoring in general, you will really like it. Like that's one of my favorite parts here.
Yeah, so first, how to stop a running container? We change the YAML. We add a new property named stopped true. And now if I watch my pod again, because I told him, okay, stopped true, this guy will kill the pod. So it's probably running, just waiting. Come on.
You haven't applied it yet.
Did I? Oh no, I just do the diff. I didn't apply. Good call.
Yeah, that's not enough. Sorry.
No, it's not. Reading the file is not enough.
Iterator is not so smart to read your mind. Sorry, you still have to do some commands.
Oh yeah, but still, okay, boom. And now it's terminating and it will shut down my running 3-node cluster. Why I do that? Because I will start a new one, single node, just to have a machine big enough to run everything. And instead of running a Cassandra node, I will run a DataStax Enterprise node. But everything else is the same. So it's terminating. I can watch, and I will delete my DC one. So my pod should be, okay, now only the cast operator there, but I still have my CRD existing. So I will just delete -F to delete as well the custom resource definition. And then I will start.
Cedric, we have to explain why we are running now DataStax Enterprise instead of Cassandra.
Oh, right. Because in the sample, I use DSC metrics exporter, which is the exporter. Let me see. I'm using the DSC metrics exporter, which is included in the DataStax Enterprise images. But we have open source the very same metrics exporter for Cassandra last week, but I didn't update the workshop yet. So you could have run in Cassandra world, but you should have update the image to have the Cassandra metrics exporter as a sidecar in the pod.
Yep. So basically now we aren't using DataStax Enterprise as a DataStax Enterprise by itself, but just to simplify this workshop, and we will hopefully adjust it to go with also with open source Cassandra for the next runs of the workshop.
Yes, and so in the background, what I'm doing is I'm simply creating everything need to start Prometheus, which is the monitoring storage unit, and Grafana, which is the web UI to show all the metrics. And then I will simply start DSC cluster and wait for the metrics to happen on the Grafana UI. So as you can see, creating now the operator both for Prometheus and Grafana, it's working the same as Cassandra. We need to create a dedicated component operator to work with those complex environments. And so I install first the operator. I create an instance that will be watched by the operator. See, I've installed the operator, the data source, and now I create my instance. Okay. And now, if I show you the service running in my namespace, I do have my CAS operator services, you know, the one metrics, webhook, and I also have my Grafana operator. And okay, where is Prometheus yet? Is it starting? And I should have applied the Prometheus Grafana, Prometheus operator created. Yeah, it should be there. And if you say no updated, already exist. Okay, right. So it will be there in a few seconds, I guess. I hope it will. Prometheus operator, yeah. No error and everything. While this guy is not there, I applying the service, I applying the operator, the data source, the instance. Yeah, see, it's there. Oh, but it did not recognize the instance. No match for kind.
Just repeat this command again. It was too quick. So
Which
operator was not finished when we started to create the instance. So just repeat it. Yeah, operator should be there, but yeah, the instance.
I got you. Yeah, it take a few sec to have the.
Yeah.
Oh yeah. So I've created.
Now, yeah, good.
No. So like for Cassandra, first I use the operator to define a new CRD, and then I instantiate my CRD. Same for Prometheus. Okay, now I've created my Prometheus CRD. And now I should have my Prometheus operated running. Yes, good point.
Cedric?
Yes?
I have a question from our quiz winner. Where can I get some info on open source data stacks metrics for Cassandra? You mentioned recently metrics exporter for open source Cassandra. Yeah,
David will share the link in Discord, I guess. But it's in the DataStax. It's a DataStax repo. So GitHub /DataStax, and you should be able to go there. It take forever. You should be able to go there and look for exporter. Just looking for one of those is DSC metric exporter. We do have the same for the Cassandra.
Metric collector for Apache Cassandra?
Yes, it's this one. Open source 7 days ago. So metrics collector for Apache Cassandra, here it is. And instead of having the dashboard for DataStax Enterprise, I do have the dashboard for Cassandra, and here it is. It will install the dashboards here. So look, it's quite the same. I simply have to put new Grafana and new operator / to match with not DSC, but Cassandra. Okay, so everything is running. I need to do the port forward. You don't have to, because if you are on the cloud machine, it's done already.
No. That's what was fixed. Now it will work on the cloud instance as well.
Okay. Yeah. All right. So please forward the port.
Before it was working for you because of the default address localhost 127.0.0.1, and now it will work on the cloud instances as well.
Okay. So now I do have Prometheus running on localhost 9090, and I do have Grafana running on 3000. So admin secret.
Password is secret.
Yes. It's written in the YAML file. Everything is in YAML file. And so where is my dashboard? Should be there. Maybe I've imported my dashboard again too fast.
Yeah, maybe.
I was running out of time, so let's go here and yet again import my dashboard.
Do we have enabled metric export at the Cassandra side, at the DataStax side?
No, there is no DataStax cluster running.
Okay.
But first I need to import the dashboards,
Oh yeah, anyway, we need
I won't, there is no data here, okay? But there is no data here, but at least I do have my dashboard. First things. So the data source is not there.
Yeah,
okay?
Maybe data source was not imported because
Yeah,
this, for everyone who has experience setting up Grafana, knows how much time it takes to set up all the things like set up the dashboard, sources, and so on to make it delivering information you need to manage the cluster. And I was really excited to see how it was just like kubectl apply, kubectl apply, kubectl apply. Boom, you have all the dashboards, fill it and prepare it from the very beginning. Without your real manual job, it's just like really cool. I was like, wow.
Yeah, and so now Grafana is restarting because there is a new data source, yada, yada, yada.
Mm-hmm.
And I will need that to be ready again. Okay, so.
You already have port forwarded. Yeah, it should work.
Yeah, so maybe it's restarting. Okay, please, Grafana restart. I see some. Okay, wait, we'll restart, I guess. Timeout. Yeah, okay, timeout.
Port forwarding may work a little bit, well, let's say it's not the main feature here. You can try to make new port forwarding with port 3001 to port 3000. Yeah, like, this one 3000?
Yeah, and 3001.
Yeah,
yes,
and
just
3000. I'm afraid what old one connection is. Nope, error.
No, I think no. I think I screwed Grafana and not
something is with Grafana. You can just delete the instance and create it new.
Yeah, I will do. That's the data source. That's the dashboard. That's service.
Instance.
Okay.
Yep.
Yeah, I'm looking for the instance.
That may be easier to delete it first.
Yeah, I will. Simply just my
UI,
just do that in the meantime.
Okay.
So now the data store is there for sure. Okay, it's already exists. All my dashboard are there for sure. And change. And I've created a get back. Okay.
Good.
Let's see how it goes. Too quick. It's not a good operator, man. I just recreate the instance. That guy should have recreated everything and working for me. It would with Cassandra. Come on. Speaking of which, let's create our Cassandra cluster.
Yeah, while waiting for Grafana, let's create a Cassandra cluster.
Yes. So let's go to
Oh yeah, that's what I mean. But we don't have cluster running yet, do we?
No, nothing running yet.
Okay.
Now, I will create a cluster named DC2 with metrics enabled, and so I can see my pod starting.
That's basically a single node DataStax enterprise cluster with metrics exporting enabled.
Yes, maybe
it's okay. It's not a single node cluster.
Yeah, I do the 3-node cluster. I do have my laptop happy to just be able to handle this stuff. Okay, and so in the Prometheus target, soon I should have my Cassandra cluster or DSC cluster appearing and starting sending event into Prometheus. and I simply just my Grafana just on strike. Because now the port is just, if I want to do the port mapping again.
If I'm not wrong, that's 7 p.m. at your site already. So Grafana maybe just want to have some rest.
Yes, who knows?
Localhost. Oh, here we go.
Yeah, the port forwarding, you know, I put something in the end. I will never to revive my dashboard. Data source. Okay.
Yeah.
Prometheus is there. Can I test my, where is test again? 7 test.
Good.
Okay, data source is there.
So Grafana can connect Prometheus, yeah.
Yes, what about my dashboards? So now I don't have my dashboard. Okay, let's put that dashboard again.
Yep.
Dashboarding. Okay, here they are. Come on, this Grafana operator is just pretty weak. It should have, you know, do the trick.
One more enter.
Yes.
Yep. So we should be here.
Yes, dashboards. Is it? Maybe it was imported in another environment. Man, my Grafana is just totally screwed.
Okay, so that's one more good reason for you to do the exercise on your own.
No, finally it was imported. It takes forever, but it was there. Okay, so Grafana is connected to Prometheus, and my Cassandra is starting.
Yeah, so we don't have data yet because it's just cluster is starting.
Yeah, but you know, as soon as I do have one of the pod ready with readiness, I hope I would have something in Prometheus and in Grafana already and would be done. Okay, so I hope on the cloud environment it was better. Yeah, I'm just looking at the question at the same time. So it's still initializing. 3 minutes, 4 minutes, it's coming. So on my laptop, I do have my 3 node running plus my Prometheus, Grafana, my kind and everything. So
you're keeping your laptop busy.
Yeah, let's wait for that guy to be awake. I will simply move back to slides just to see. Okay, we have started Prometheus and Grafana, so the operator, the instance, and the dashboard 2 times. And then we have defined some services in the Prometheus metrics collection using DSC metrics to be able to read metrics coming from DSC container, leveraging on collectd, and sending metrics into the service monitor. And that should show up in Grafana. Simple as that. And this is what we just did. And come on, running.
Yeah.
Okay. Still nothing there, but it's still liveness, not readiness. Hope I would get something at last. Yeah, anyway, I've done nothing wrong, just get too fast. Because my laptop was busy sharing. It's fun. most important part was really to make my Cassandra cluster scale and update config. Now it's just showing some nice features. So running 2/2, 1/2. Okay, what about my... Okay, why do I have not any status targets? Now it's Prometheus that is on strike as well. And it's running. Come on, guys.
Did we do all the steps? Because maybe we missed something like enable exporting or anything. Let's double check.
Okay, so first let's check for the data stack stuff. So we want to execute something called enable metrics, right? So this guy is here, enable DSC mini enable metrics. So I go to cat 3 and its name is DSC/DSC mini enable metrics. So, and yes, I do have my port open and I'm writing stuff. Okay, and now when I've installed Prometheus, browse DSC cluster. So Grafana, Prometheus, okay. Operator is okay. Instance is okay. Service monitor, yeah. So the service monitor is registering the listener from Cassandra to Prometheus. I mean, if this one, okay, this one was not there. Okay. Makes sense.
Yeah.
Yeah, but should I restart my cluster? No, I shouldn't have. Probably starting. Okay.
Oh, yes.
Now it's coming. Yeah. So I do have my Prometheus watching some DSC cluster telling me that it's up, 2 are up, 1 is down, starting, connection refuse. And that makes sense because the last guy is still in liveness but not readiness. So that match what I do have. And so if I go to my cluster now,
yeah, it has some information already.
I should have, yes, 2 nodes ready and data, inbound data incoming. So my first issue was to create not to create the Grafana instance, okay? No, forget the dashboard, forget the instance, and forget the service monitor. Wow.
Never mind.
What a teacher. No, they're just kidding. But yeah, best thing is now it's there, it's working. There is no issue, my third node will be there.
Well, but you know, live investigation of an issue, always interesting. That's like a thriller or detective movie. What happened? Why it doesn't work?
It's yeah, I love it. It's real life, you know, it's not a movie.
Yeah.
Okay, so we are 15 minutes late already. Time to close a bit. So we do have a lot of resources for you to share. So first, if you want to know more about Cassandra, we provide the academy.datastacks.com with tons of courses. And I do have the link in the next slide. If you ask questions about Cassandra, you can go to community.datastacks.com where we provide, we will answer your question for free. It's Stack Overflow for Cassandra. If you like the content of today, which was mostly ops, but if you are dev and would like more dev content, please subscribe, put a thumb up, go and subscribe to Twitch and Twitter as well. All the slides and the code for today are on GitHub, but now you can tell because we have done everything on GitHub. And if you like speaking about Cassandra and Kubernetes, We will do a live session next Tuesday, so May the 19th, with Patrick McFadden, with a panel on expert on how to run Cassandra on Kubernetes. And we already have the first part which has been recorded, and it's available on datastax.com/accelerate. Those are the courses on the Academy. This is Cassandra, the Definitive Guide, so 3rd edition by one of our colleagues, Jeff Carpenter. This book just released. You can have a free copy. Just go to this link, datastax.com/resources/ebook/Ori Cassandra Definitive Guide. And yeah, with the help of DataStax, you can have a free copy. And I will share the link in Discord as well. Because you attended today, you also can have, as stated in the welcome email, you can try to take the Cassandra certification. We can have you a voucher. So we have shared yet again the certification voucher link in Discord. So you will have to go to academy.datastax.com and take the courses there. It's about 30 hours video total, 3 courses to pretend to be able to pass the Cassandra certification. But hey, you do have the voucher, you can test. It used to be $400, so that's still a good opportunity for you to pass the certification. Those are incoming events. So next Monday, Cassandra Developer Workshop, 3 hours fully on Cassandra. Tuesday, the Accelerate Kubernetes panel. Wednesday, yet another workshop, this time on the Cassandra as a service offer named Astra, with again hands-on. And as you can see in the week after, yet another workshop on both Cassandra or open source or free tools we are provided.
Sorry, one more point. If by any occasion I have some Russian-speaking friends here in the chat, in the workshop, we have a very first Cassandra Day Russia on 29th of May, all the Russian language, of course, with workshops and talks. So I suggest you to find Cassandra Day Russia and join us. Yeah. Sorry, Cedric, but it was important to say.
Oh, yes, of course. One last thing is also, during the pandemic, we're providing free support for Cassandra cluster running on production. And we are now also providing support on the APAC region for that. So don't hesitate to go to datastax.com/keepcalm and find a slot, and we will have our SRE happy to help you during office hours about your issue running Cassandra clusters in production. We are doing that as well.
Take a look. That's a serious offer, because usually this kind of audit and checks and consulting is, well, pretty expensive.
Yes, and that's what it is for today. Stay just a few minutes for the survey. But what next? We are providing you a working sample. And we are providing you working sample, working code, containers, test by yourself, provide some feedbacks, start using Cassandra. And yeah, of course, we are here to answer any questions. And with that, let's move to our survey.
So we said so many great things today. Now it's your turn to say something, what you think about this workshop, and when we are done.
Okay, I can see that you there, guys. 15. Yeah, let's finish by a little survey.
Yeah. There is no correct and wrong answers this time, and no swag additionally, sorry.
Yes.
But we want those workshops to be regular, A, and great, B. And we need your answers to make it real. And subscribe to our YouTube channel. We have some regular great things there.
Okay, so I think we do have 5 questions, something like that, 5 to 6 questions, so it will be quite quick. Okay, so first one. How likely is it that you would recommend this event to a friend or a colleague? Whoa, what a note! 9.8, nice. Oh, now it's only decreasing now.
Come on, 8.9 is still a great answer.
Yes.
Still a great number. 9.
Live debugging in front of you. Okay, 9.1. Okay.
Thank you, everyone. Thank you.
Yeah, thank you. 9 is very nice. Question number 2. How long should those workshops last? So is 2 hours the good spot? Should I make it longer than 3 hours? We used to do 3 hours, but for people, seems too long? Yeah, I think 2 hours remain the sweet spot, even if we tend to go a bit more time, but hey, we need that 10 more minutes to debug this time.
For the people who say it's half a day, we do have really a lot of great content at the academy.datastacks.com about the Cassandra and all the related technologies. So if you need more, go to the Academy.
Please. All right. 16, we do have our quota. How easy was it to get help during the workshop? So now, David, we are looking at you. And on all DataStax people helping on the Discord chat, of course. It's not only David. And not only on Discord, but also probably question on YouTube and Twitch as well.
I hope no questions on Twitch. We don't have so many people to watch literally every channel. Twitch is a backup one for us. If anything happens with YouTube.
Discord 1, YouTube 2.
Yeah, but we have people on Twitch. Yeah, we have people on Twitch.
Extremely easy. Nice. No, come on. Now I need to wait somebody to say very easy. Okay, 16, we do have everyone. Let's move. How easy was it to attend? So, Discord plus YouTube. So it's not only YouTube to get your hands and to get your question. We have Discord. Oh, extremely easy. Nice, nice. So we add this new slide explaining you do have your stream in one side, the browser in one side, and having Discord on one tab, and finally having your terminal. Yeah, good.
I would better keep everything at one place, but at this point of time, it's not possible, basically.
Yeah, it's not the same tools yet.
Yeah.
Okay. One more question, I think. How did you hear about the event? So multiple answers possible. DataStax Academy, Twitter, LinkedIn, Meetup, Eventbrite, Discord, YouTube, Twitch, and direct email. But also you can say that you attend to a previous one and you like it and you come back. Who knows?
Okay, the 1 person, 2 persons who came, or 3 persons who came from YouTube. Thank you. Now I know I'm scheduling these events on YouTube for a purpose. That's great.
Yes, and you can see that we have already multiple events scheduled already. So for more developing content, more Cassandra content, more cloud content. So every week, the same time, and sometime we add another date. And it was my last question. Again, thank you for your time. I appreciate to do this workshop. Hope you liked it, and hope we see you next time for next workshop about Cassandra.
Thank you for coming. Thank you.